Imagine there are 100 closed doors lined up in a hallway. You'll walk past them 100 times. Each time you reach a door, you may toggle it. That is, open a closed door or close and open one. On the first pass, you toggle every door. On the second pass, every second door. On the third pass, every third door. You continue this pattern until the 100th pass, where you toggle only door number 100. When you are done, how many doors will be open? At first glance, this looks like a problem about keeping track of doors, but that is almost impossible. Instead of following every single toggle, let's see if there is a simpler pattern hiding underneath. To make things easier, let's forget about 100 doors for a moment and start with just 10. Initially, every door is closed. On the first pass, every door is toggled, so they all become open. On the second pass, every second door is toggled, so doors 2, 4, 6, 8 and 10 close. On the third pass, doors 3, 6 and 9 are toggled. Continue this process until the 10th pass. As you can see, keeping track of every toggle quickly becomes impossible. So instead of following every door, let's ask a different question. Let's focus on door 12. When is it toggled? Passes 1, 2, 3, 4, 6 and 12. Notice anything? Those are exactly the divisors of 12. And that's the key observation. A door is toggled exactly once for every divisor of its number. So now the puzzle changes completely. Let's look at the divisors of 12. Every divisor has a partner. 1 pairs with 12, 2 pairs with 6, 3 pairs with 4. That gives us 6 divisors. That is 6 toggles. An even number of toggles means the door ends up exactly where it started. Closed. Now let's try door 16. Again, the divisors form pairs. 1 pairs with 16, 2 pairs with 8, but something different happens with 4. Its partner is itself. Since we don't count it twice, door 16 only has 5 divisors, 5 toggles. An odd number of toggles leaves the door open. And that is the entire secret. Every non-perfect square has its divisors neatly paired, giving it an even number of divisors. But every perfect square has one divisor that doesn't get a different partner, its square root. That's why perfect squares have odd number of divisors. So after all 100 passes, the only doors left open are the perfect squares. Exactly 10 doors remain open. What I love about this puzzle is that it tricks you into thinking about doors. But the doors are just a distraction. The puzzle is really about divisors and a beautiful property of perfect squares. Once you recognize that, a problem that seems impossible becomes surprisingly simple. If you enjoyed this video, consider subscribing for more math puzzles like this. Thanks for watching, and I'll see you in the next one.